Hello everyone, you're welcome to this channel once again. Today we have another question from aerodynamic point of view. Now let's read through the question we have today. Consider a finite wing with an aspect ratio of 8 and a taper ratio of 0.8. Assume the airfoil section is thin and symmetric. Calculate the lift and the induced drag coefficient, that is CDI, for the wing when it is at an angle of attack of 5 degrees. Assume that delta, which equals to tau, equals 0.055. Now, let's assume we have a finite wing representation. CL here, angle of attack alpha here, with the gradient which equals A. Now, how do we calculate the lift-induced drag coefficient for the wing? Let's pull out the parameters. Today we have a finite wing. We have the aspect ratio to be 8. We have the angle of attack to be 5 degrees. We have the taper ratio to be 0.8. We have the delta to be 0.0555. We have the tau also to be 0.0555. Don't let us forget that the CL over the alpha equals AO, which equals 2 pi. Don't let us forget that the aerofoil is thin and symmetric. So therefore, CL equals A alpha minus alpha L. It becomes 0. So therefore, this becomes 0. So therefore, our CL equals A alpha. So now that our A equals A alpha, our dCl over d alpha equals A. And how do we calculate A? Which is a gradient for the equation of the coefficient of lift to the angle of attack. A is known to be AO over 1 plus AO over pi aspect ratio 1 plus tau. Let's put in all the values. We know that our AO from the reference here, AO equals 2 pi. So that becomes 2 pi over 1 minus 2 pi over pi multiplied by our aspect ratio is 8 multiplied by 1 plus what's our tau or deflection, which is 0.0555. That gives us 5.08 radian per radian. And to convert per radian to per degree, it becomes 5.08 multiplied by pi over 180. That gives us 0.08866 per degree. Now that we have gone our value for A, the next thing is to find the coefficient of lift by using the respective equation that say CL equals A alpha. That gives us 0.08866 multiplied by the angle of attack, which alpha, which is 5. That gives us 0.4433. And don't let us forget that the equation for the coefficient of drag, CDI, equals CL squared over pi AR 1 plus delta. That gives us 0.4433 squared over pi times 8 multiplied by 1 plus 0.055. Our calculated CDI, which is a coefficient of induced drag coefficient, equals 0.00825. Thank you very much for staying tuned to the end.